in this homework we look at the 3 basic rules of indices. Indices is another word for power, and all of the little numbers here in superscript are indices. If we've got one of them, it's called an index, not an indice as some people try to call them. They are one index, several indices. So let's have a look at the first law of indices, which is to do with multiplying. So we have here 6 expressions with 2 terms in each, and the 2 terms are being multiplied. Now when I talk about the parts of each term, I'm talking about the index or the power, which in this case is 4, and the base number, which in this case is 2. Down here the index is 9 and the base number is 8. Down here the index is 4 and the base number is 8, because we don't know what it is. Right, so every time, if the base number is the same, the base number stays the same, so this will be 2. But the powers, what we do with the powers is we add them, because I'm multiplying. I've got 4 2's multiplied together here, and I've got another 4 2's multiplied together here. So in total I'm going to have 8 2's multiplied together. That is not the same as 2 times 8. That is 2 times 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 2. Very different to 2 times 8. So again, our base here is 5. It's the same base, which means it stays as 5. It doesn't change to 25. And then we've got power of 5 here, and we've got power of 8 here, which means altogether we've got how many 5's multiplied together? 13 of them, because we add the powers. Base number here is 6. Our powers are 3 and 7, which means altogether we have got 10 6's multiplied together. Our base number here is 8. We're multiplying 8 to the power of 9 and 8 to the power of 9, which means in total we've got 18 8's multiplied together. Now our base number is A. So we don't know what our base number is, but it doesn't matter because we're just simplifying. We're not calculating the value. And then our powers are 4 and 8. So in total we have 12 A's being multiplied together. And for this one our base is N. N is quite frequently used as it's short for number. And we've got 8 to the power of 8 here, to the power of 9 here, which means in total we've got 17 n's being multiplied together. Right, sorted. Now, when we divide, we subtract the indices, and that's because when we have any number divided by itself, it gives us 1, which incidentally is also any number to the power of 0. Any number to the power of 0 is 1. And that's because if you've got no 7's being multiplied together, you've just got 1, your base. You haven't got 0. Really important to remember that. So again, so long as the base is the same, which it is, the base stays as 7. And this time we look at the indices, we look at the powers, and we subtract them. Because 2 of these 4's are going to be cancelled out by, 2 of these 7's are going to be cancelled out by these 2 7's, which means in total we'll have 4 take away 2. We'll end up with 2 7's being multiplied together. It doesn't want the answer, it doesn't want to know that it's 49, it just wants to know that it's 7 to the power of 2. Base is the same, which means we can use 5. 17, subtract 9, gives me 8. The base is the same. 13, subtract 6 is 7. In case you're wondering, yes, we can have negative powers, and if you do indices 2, that will have negative powers, and I'll explain in that what that means. Base is the same, and we subtract the powers. Into letters, but remember it's exactly the same idea. Our base is E, and we've got 12, subtract 6, the power of 6. Our base here is G, and we've got 12, subtract 9, G cubed. Okay, so all of those are 1 mark questions, and they would be 1 mark questions in an exam as well. They would probably be the multiple choice questions. Simplify this for this one. Okay. Right, now we have brackets. Brackets are Brackets are slightly different because this time we are saying we've got 3 4's multiplied together, and then we're multiplying that together 5 times. So we've got 3 4s multiplied by 3 4s multiplied by 3 4s multiplied by 3 4s multiplied by 3 4s. So again, we're still interested in the base number, which is still 4. But this time, we're going to multiply the powers together. So I've got 15 4s being multiplied together there. Same idea here. We've got base number of 5, and then 5 power of 5 to the power of 5 would give me 5 times 5, which is 25. My base number here is 9. 9 to the power of 4 to the power of 7 means I'm doing 7 times, which is 28 9s being multiplied together. That would be quite a huge number, because 9 is a large base, and then we've got a really huge power like that. That's why we often don't calculate these. 4 is our base here. 6 times 6 is 36. Now we're back into letters, but remember that's absolutely fine. It just means it's a number we don't know yet. 7 and 5 means we've got 35 A's being multiplied together. And finally for this side we've got G as our base. I've circled it as underlined all these, never mind. And we've got 5 G to the power of 5 to the power of 7, which means we've got again 35 G's in total. Now these are a couple of questions that might throw people off. Okay, so let's have a look. We've got 17 to the power of 4 divided by 17. What some people will do there is, oh, 17 divided by 17 is 1, so it must be 1 to the power of 4. No. How many 17s have I got? Am I multiplying here? Oh, I've only got 1 17. So whenever you've got the number on its own, the base number on its own, think about it as being to the power of 1. So what have we got here? We've got a base of 17. And then we've got the power of 4 divided by the power of 1, which means we're taking away 7 to the power of 3, 7 cubed. Same kind of thing here. This is e to the power of 1. So our base is e. And we're multiplying, so we're going to do 4 e's multiplied by 1 e, which means we're multiplying 5 e's altogether. Alright, here, a is our base. And then we've got 7, we're dividing, so we take away 6. 7 take away 6 is 1. Do we need to put a to the power of 1? No, we don't. We only need to think about that in our calculations. It's like when we write x. We don't write 1x, we just write x. So here, this is a to the power of 1, but we're just going to write a because, apart from anything else, there is no power box for us. N to the power of 0 to the power of 3. So our base would be n. I'm going to write this over here and you'll see why. And then our powers are 0 and 3, and power to the power times 0. Then 0 times 3 is 0, 0, n to the power of 0. Now that means I'm not multiplying any n's together. The answer to anything to the power of 0 is always 1. That is just a law. Anything to the power of 0 is 1. Always. Always, always, always. Okay, so let's have a look at this one. We've got x to the power of 9 times x to the power of 7, which gives, so my base is always x. Yes, x, x, x. That's group, isn't it? 9 and 7, and that's going to give me, add them together, it gives me 16, and 16 on the bottom, so 16 take away 16, that gives me x to the power of 0. But I can't fit x to the power of 0 in there. But we've just said, what have we just said? We've just said that every single number, doesn't matter what it is, to the power of 0 is 1. So 375 billion to the power of 0 is 1. Okay, 1.